This is Gail Kovac for Gresham Barlow School District. This is Summer School High School Credit Recovery for Algebra 1B and Learning Target number 10. I can identify the domain and range of a quadratic function. So we've looked at domain and range a couple of times now. You've seen it more in depth for Learning Target number 10. And what we're looking to do is identify what are all the values for x and what are all the values for y for this function. That is x for domain and y for range. Now for quadratic or parabolic functions, that's that U shape that kind of turns around and starts going back in the other direction. Note that they do extend forever in this one direction on both of these sides, even though it might not show it on the graph. So that's something to consider. All right, so let's go ahead and start with domain, which is what are all the values for x. So although this is mostly tilted upwards, it is also slightly tilted to the side, meaning that this function will continue indefinitely all the way over to -infinity for x. And likewise, this portion will continue upwards forever and slightly more and more and more this way forever. So it is actually unbounded in the x direction. So it will eventually take on all possible values for x. So for the domain, we're going to say all real numbers. There are no limitations for what x can be in a quadratic function. Now let's try range. Range is how far up and how far down this function can take values for. I notice that it does go up and up and up and up and up forever. So for the y direction, that's the vertical component, that is going to go up and up and up forever. However, it does have a bottom. See here how it bottoms out at -4? That's the lowest value that y can possibly be right here at -4. So y can be all values that are greater than or equal to -4. You can write that as an equality. An inequality like this has to be greater than or equal to -4. That's inequality notation, or you can write it in interval notation, which is kind of like a coordinate point. It's the minimum number, then the maximum number with a comma in between. So my minimum number is -4 exactly. I'm going to put a square bracket around that exact value. And then it does go up to infinity. And for the infinity side, we're going to put a rounded bracket because infinity is a concept, not a solid, straight, actual, precise number. So we're saying it's somewhere around infinity, wherever that is, but starting at exactly -4. All right, let's try it for this function over here. So again, domain is for all values of x. And that does go slightly left forever and slightly right forever. So my x's can be all real numbers from positive to -infinity. And the range, which is the y, it looks like this one does have a bottom, but it does go up and up and up and up and up forever. So we can go all the way up to positive infinity. And we do, however, have a bottom. It looks like this one bottoms out at -3. So that's the minimum value. That parabola is not going to turn around and go any lower than that. It's always going to be higher than that. So my y values can be greater than or equal to -3. Or if you prefer to write it in the interval notation, my values start at a minimum of exactly -3. And then they go up forever and ever and ever into somewhere around infinity. So for these, you don't have to put the inequality and the interval notation. If you want, to be extra thorough, you can. You can just do one or the other, which one you prefer. But for all of these problems, all real numbers is what you're going to put for the domain, because that's just something that's true of parabolic functions. Now, if the parabolic function turns upside down, then you're going to have y as less than, and your hard maximum will be on this side instead with a negative infinity and a rounded bracket. Just something to note.